GPS, or Global Positioning System, is a navigation system that uses satellites to provide location and time information anywhere on Earth. It was developed by the United States Department of Defense and is now widely used for civilian applications such as navigation, tracking, and surveying. So how does GPS work? GPS consists of a network of satellites that orbit the Earth at a height of approximately 20,000 kilometers. These satellites constantly transmit signals to GPS receivers on the ground. A GPS receiver needs to be able to receive signals from at least 4 satellites to calculate its location. The receiver measures the time it takes for each satellite signal to reach it and uses this information to determine the distance between the receiver and each satellite. This is known as the range or pseudorange. The GPS receiver also needs to know the precise location of each satellite. This information is included in the satellite signal and is known as the ephemeris. The GPS receiver uses the ephemeris data to calculate the exact position of each satellite. Once the GPS receiver has determined its distance from at least 4 satellites and the exact position of each satellite, it can calculate its own position using a process called trilateration. Trilateration is similar to triangulation, but it uses distances rather than angles to determine position. In trilateration, the GPS receiver determines its distance from each satellite and then creates a sphere around each satellite with a radius equal to that distance. The intersection of these spheres gives the receiver's position. To improve the accuracy of GPS, receivers also use a process called differential GPS, DGPS. DGPS involves using a known location to calculate the difference between the actual GPS position and the position that the GPS signal indicates. This correction factor is then applied to the GPS position, resulting in a more accurate reading. In summary, GPS works by using a network of satellites to transmit signals to GPS receivers on the ground. The receiver calculates its distance from each satellite and uses this information, along with the precise position of each satellite, to determine its own position using trilateration. GPS is a powerful tool for navigation and location-based applications, and it has become an essential part of modern life.